Just remember, contraction is systole, relaxation is diastole. Total duration of cardiac cycle 0.8 seconds, of which systole is 0.27 seconds, diastole is 0.53 seconds. So these are the steps which are seen in the cardiac cycle. Atrial systole. Atrial systole is, this is for convenience, we are starting from the atrial systole, which actually marks the last stage of diastole. So basically the atria will contract to release whatever small amount of blood is present in it into the ventricles. So in this case, the atrioventricular valves are open so as to allow the movement of blood from atria to ventricle. Semilunar valves, which are present on the aorta and the pulmonary artery, are closed. Okay. Then we move to isometric contraction. Isometric. Iso means equal, metric length. That means length of the muscle fibers remains same. The tension within the muscle fiber increases. Length remains same, tension within the fibers increases. That's why it's called isometric. When this happens, the tension within the ventricle increases. This in turn leads to an increase in the intraventricular pressure. For this to happen, all the valves must be closed, isn't it? Yes? When you cook rice in a pressure cooker, that weight you have to drop it down, isn't it? If you leave it, if you pull it open, will the rice cook inside? No. The same way, all the valves should be closed. Only then will the isometric contraction occur and the pressure buildup occur within the ventricles. This is clear? Okay, that's isometric contraction. Once isometric contraction occurs, the heart is ready to eject the blood from its surface. That means now the pressure within the ventricles is more than the pressure inside the adjoining blood vessels. That means on the right side, the pressure is in the right ventricle is more than that of the pulmonary artery. On the left side, the pressure in the left ventricle is more than that in the aorta. Got this concept? Correct. If the ventricles get tension within the ventricle increases, obviously the pressure will exceed that of the vessels around it, isn't it? Okay. Once more. Okay. Which part? Isometric contraction? Okay. Okay, isometric contraction. Isometric contraction means it's a condition where the length of the muscle fiber remains the same, but the tension within the muscle increases. So what happens here is, once ventricles are filled with blood from the atria, once the ventricles are filled with blood, okay, what happens is the pressure in the ventricle starts increasing. Correct? So already the volume of the ventricle is more because blood has flown in and filled it up. After that, all the valves will close. So it becomes like a pressure cooker. And then the tension within the ventricle increases. When the pressure increases within the ventricle, it exceeds that of the nearby vessels. That means on the right side of the heart, the right ventricle's pressure will be more than that of the pulmonary artery. On the left side of the heart, the left ventricle's pressure will be more than that of the aorta. This much is clear? Clear? This is isometric contraction. Once this happens, okay, once this happens, the next stage is to remove the blood from the ventricles because the pressure has become too high. So the next stage is the valves which are present in the blood vessels will open. That means the semilunar valves will open and the ventricles will contract and pump the blood into the aorta and the pulmonary artery. This phase is called the ejection period. This is called ejection period. Is this clear? Just see it as a sequence. Basically what happens in heart? Ventricle fills, heart pumps, releases blood, blood returns back. The same thing has been subdivided into steps. That's all. Okay. So here in ejection period, what happens is the ventricles contract and then the blood is released into the major vessels. That's ejection period. After this is a phase called proto-diastole. Proto-diastole means the systole has ended. Systole is basically isometric contraction and ejection period. Once that ends, it means proto-diastole. That means relaxation. Okay, so that means the ventricular pressure will start decreasing. The semilunar valves close. Semilunar valves close, and this in turn allows the ventricles to relax. That is the next stage, which is called isometric relaxation. In this, what happens is length of the fibers remains the same, but the tension in the ventricles is gradually reduced. So the ventricles start relaxing slowly. Here, all the valves are closed. Very important. All valves are closed during isometric contraction and isometric relaxation. Isometric contraction and isometric relaxation. Then you have rapid and slow filling. How this happens? If the ventricles relax, ventricles are relaxing, okay? All the valves are closed, ventricles are relaxing. If the ventricles relax, the pressure in the atria will build up, correct? Volume of blood in the atrium will be more. So obviously the pressure will build up in the atria. So the atria cannot hold the blood for longer time. So in turn, what happens is the AV valves and the other valves will open, allowing the blood to move in from the atria to the ventricles. This is called rapid and slow filling. This is called rapid and slow filling. That is it. This is the, and after that again it reverts back to the atrial systole. This is the cardiac cycle. Okay, so you have atrial systole where the atria contract and release the contents, okay, last of their contents, right? And then the ventricles will relax. Semilunar valves are open for a very short period of time and it closes quite immediately. Okay, but just as a theoretical thing, it is mentioned, semilunar valves will close immediately. Okay, for a brief period of time,